So this is the cryptocurrency that we are gonna build on Ethereum block by one cryptocurrency. So we click on buy. So in this tutorial, we will build our own cryptocurrency on Ethereum blockchain. So if you don't know anything about blockchain, cryptocurrencies or Ethereum, so this video will be a best start for you to enter into blockchain space. And Ethereum 2.0 is releasing, so building cryptocurrencies on Ethereum blockchain, you must know that, because this is the skill that will be hot in 2021. So let's get started. So this is the application that we are gonna build on in React.js. And if you don't know React, then don't take worry, we will cover React.js from scratch, and also we will build our own token and smart contract from scratch, so don't take worry. So as you can see in this application, like devtoken ICO sale, this is showing our address. In blockchain we generally do transaction by addresses. So we will cover that topic in a bit. Generally what this application do is, like, there is a ICO, so this is initial coin offering. So anybody can come to this website and there is a rate set, like one coin of this cryptocurrency is of 0.01 ether. So one cryptocurrency is equal to 0.01 ether. So let us buy one cryptocurrency. So we click on buy, and you can see that this is showing us price 0.01. so let us confirm it and let us refresh. So yeah, we have bought one cryptocurrencies. You can see that initially it was 25,100 and now it is 25,1001. So now we can click on the transaction and see that one dev token has been transferred to our account. So that is cool. So we will build so this is the cryptocurrency that we are gonna build on Ethereum blockchain, and this is the sale contract that we will build on Ethereum blockchain. So we can click on cryptocurrency and know, like this, and all these transactions. So these are the transactions, and let us get started. So as I have told you, so first of all let us cover what is initial coin offering. Initial coin offering can be compared to as IPO. So IPO is equal to initial public offering, in which big companies come and they sell their shares. Similarly, we are launching a ICO, so we are coming up with our token or cryptocurrency, and we are selling that cryptocurrency by launching an ICO in public market. That's pretty much it about the initial coin offering. Now we will cover some concepts about blockchain. So basically, what is blockchain? Basically, blockchain can be defined as peer-to-peer network of nodes. Each node is talking to one another. So what do you mean? What I mean by node? So let us take an example of a database. So if I are participating in a blockchain, like let us take an example of, like, we are participating in Ethereum blockchain. So each node, like me and you are a node. So you are a node and I am also a node. So each node has all the copy of a database. You also have a copy of a database. So each node is talking to one another and checking that each node has proper copy of database. If there is any error, then that node will not be considered. Let us just take as an example. So this makes all the blockchain a decentralized database, because all the nodes contain all the database, and any transaction, like that I did transaction in this, So this transaction is gone to each and every node, and that's why it is decentralized. And what are smart contracts? Smart contracts are decentralized code or logic on blockchain that commands the particular transaction to take place. Like these smart contract, so in this initial coin offering website, when we interacted on and we clicked on buy token, then this buy token interacted with the smart contract, and this checked that if we have paid the Ethereum, then the smart contract is going to give us one cryptocurrency. So smart contract cannot be hacked, because the best thing about smart contract is immutability. So let us take an example how our old website work. Old website culture works like there is a centralized server, and that is interacted with the front end, and all the data is stored on centralized server. So there are some chances, like any centralized authority, like let us take an example of election, or let us take an example of ICO. So if a person has a one cryptocurrency in his account, then any centralized authority can change that to 100 or 1000 or 10,000, and that is I think changing the data. But in smart contract, they are immutable. Once they are deployed, their code cannot be changed, and the transaction cannot be changed, because each and every transaction is happening on Ethereum blockchain. That's because all the nodes are connected to each other and talking to one another. So welcome to my another video on this cryptocurrency series. So in this video we will start making our own cryptocurrency. So before making our cryptocurrency, there are certain set of rules and regulation that we have to follow according to Ethereum, so that Ethereum can consider our cryptocurrency as a valid cryptocurrency, so that we can launch our ICO in a successful manner. So there are certain set of rules, like how transaction can be done, and how the tokens can be transferred, or how we can receive the tokens, and some features like this. So let us get started with the features. So first of all, there is a function that we have to write in our code before when we will be writing our cryptocurrency. Then we have to specify this in our code, because if we will not specify these feature in cryptocurrency, then Ethereum will mark our cryptocurrency as invalid. So first of all, there is a function of name. So leave the syntax. We will code our cryptocurrency in solidity language. So don't take worry, solidity is very much similar to JavaScript and C++, so it's not an issue, very easy language. And even you can code your cryptocurrency in about 100. So we have to keep a function called name that will return string. So if we are deploying devtoken to Ethereum blockchain, then the name must return devtoken when we call it. Then there is a function called symbol. So we have to write symbol. So when we will call symbol, then it must return the short form of our cryptocurrency. So there are two things, like let us take an example. There is one thing, devtoken, then the short form of devtoken is DEV, and DEV will represent our token, our cryptocurrency. So then there is a function called decimals. So decimal is like let us take an example, like $1 equivalent 75 rupees in Indian currency. So similarly, 1 Ethereum equal to 1 into 10 to power 18. So this is like a rule that is set by Ethereum, like 10 to power 18 must be considered. So we will build our cryptocurrency by keeping the decimal 18. So if we will send one crypto to it, then we have to apply 18 0 after the 1, so that 1 will be received by another person. Okay, so there are various functions, so we will write this function step by step, and we will keep looking into. I will share this link in the description. We will move toward making our cryptocurrency. So as I told you that we will build our cryptocurrency in solidity language, so we will write our solidity code in Remix IDE. You can search Remix in Google Chrome and then click on solidity, and it will install all your code, all your dependencies. Then you can just click on plus button and we can create our cryptocurrency. So we can name it as devtoken.sol. So before starting writing the smart contract, we have to define what version we have to use to write solidity. So we will be using 0.7.0 version of solidity. So it is like a boilerplate code that we have to write pragma solidity cap 0.7.0. Now we are writing smart contract. So when we write smart contract, then we have to give contract keyword to start writing the smart contract, and the name that we want to give our contract, that we can write after contract. So we are gonna write dev token to it. So this is initialization of smart contract and is showing us errors. So let's delete this. Okay, so we will set the version to 0.7.0 here, and it will not show us error anymore. So it is compiling. Dev token is compiling success. Now we will start writing our smart contract. So as there are integers in normal programming languages, similarly there are integers in solidity. So we call integer in solidity as uint 256. So uint 256 means that the value of this variable can't be negative. So this data type can't be negative. So if I define uint a, then the value of a can't be negative, otherwise the value will give us an error or overflow. So as you know that there are two types of variables, there are two types of keywords, public and private. So public keyword is for public, that we want to make this variable public, and private are for that we want to make this variable as private. So in solidity, if we give any variable public, let us set this to 5. So what solidity do is, it will create a get function to it, and automatically. So if we will compile the code and go on to this part of Remix IDE, so this part is deploy and run transaction. So let me explain quickly to you what these are the accounts. So we have currently 1000 ether in 10 accounts. So what is gas limit? So let us take an example, like if you use credit card or debit card, then when you do transaction or go to your bank account, then some fees is deducted in form of tax. So gas is similarly like that. So when you do a transaction, so some gas is used, because blockchain is a chain of blocks, and each block when generated is the process of generating a new block in blockchain is called mining. So when we do a transaction, then a block is generated in every node. So That's why some gas fees is deducted from our account when we do a transaction. So simply this means that, so value in, we leave that for now, and this is the token, dev token, it is showing to us, and let us click on deploy. So this is the smart contract. So as I told you that when we declare any variable public, then it will create a getter function for us. So when we will click on it, then it will return 5. Similarly, you may have interacted with functions in normal programming languages. So if you have not, then in function is basically a set of rules that is defined, and that can be called again and again, and that can be called with different values. So we define function by writing function and then name of function like set value of a, because in this we will set value of a to anything. So and let us close with this parenthesis, and we want this function to be public, and close this function. Also we want this function to take input from the user, like we want to change the value of a to another, like we want to change the value of a to from 5 to 10. Then this function will take input from user. So we want to take input from user in the form of uint, in the form of positive value. So we will write this, and we will type /_ a. So we will set a to _a. So I think this is correct. Now we will delete the previous deployed smart contract, and you can see that when we deployed the smart contract, and some gas fee is deducted. So we will deploy dev token to it, and you can see that there is a function called set value of a. So we will let us first fetch the value. So this is showing us value 5, and now let us set it to 10 and set value, and just you can see that the value of a has changed from 5 to 10 because we set value of a from 5 to 10. Now we will start coding our cryptocurrency. So as I told you previously that we have to follow some set of rules so that Ethereum can accept our cryptocurrency as valid. So I have divided the set of rules into parts. So we will do our coding of cryptocurrency step by step. So in first step we have to cover these 4 points. So we have to give name to our cryptocurrency, symbol to our cryptocurrency, the decimal that we are using, the decimal that we will be using for our cryptocurrency, like $1 equal to 75 rupees. So similarly, cryptocurrency also has a like conversion. So 1 Ethereum equal to 1 into 10 to power 18. So similarly, we will also keep our cryptocurrency equivalent to Ethereum decimal so that we can have a conversion later on, and we can launch our initial coin offering and as a conversion parameter. So and we will also define a variable, a uint positive variable, so that in this we will keep total supply of our cryptocurrency in it. Like we will be launching 1 million cryptocurrency, so we will be storing that amount in this, and whenever we will be clicking on total supply, then it will show that the total supply is still 1 million. We will be giving a name to our cryptocurrency. So for giving a name we will use keyword string because we are storing character in our in this variable. So just define it as string and give it keyword public so that we can get a get function and we can call and get the name of cryptocurrency, and just give it name, and we will give it name as dev token. And symbol, coming to symbol, so cryptocurrency has two names. One is the proper name, like I am giving dev token to it, you can see in the screen that the name of this cryptocurrency, that is on Ethereum, it is over sold in billions and trillions. And as this is cryptocurrency, the name of cryptocurrency is Tether USD, and the short form of it is USDT. So whenever you and I want to buy some USDT, so we will call it as that. We don't call it as we want some Tether USD. We will call it as USDT as a short form of Tether USD. So we will give a name of our token. So we will give short name of our token as DEV, Dev token. So string, symbol, and public symbol, and we will give name it as DEV, capital DEV, and we will give decimal of our cryptocurrency as 18 because we want to convert it with Ethereum, and just type uint 256, uint 256 for positive integers, and name it as public because we want to get we want to have a get function, and just give it as decimal, and we will store it as 18. Now we will define a variable in which we will keep the total supply, and just give it as public and name it after total supply. Now we will complete the rest of the cryptocurrency in later on part. So till then, bye bye. So we are continuing our cryptocurrency where we left off in the previous part. Now here we will define an array in which we will store the balance of corresponding address in it. Like if you have an address particularly of a wallet and you contain 100 ether, so we will store that in it, but not ether, we will store our cryptocurrency balance in it. Like we will store the amount of cryptocurrency that a particular person holds corresponding to its address. So similar, when we use array in simple programming languages, using array, so we just simply call it as, if we want the value which is at index 1, then we simply write a1 like this, and this will return the value stored in it. Like if there is an array and it contains 1 2 3, and we want to get 2 value from this array, so we will just simply write a1 in it, and a1 will return 2, and that is true. Similarly, if we want to store address of a particular person in this array and want to get the balance of it, that is not possible in this array. So solidity has a keyword mapping in it. So mapping, generally what it does is, like we can define our own array according to our needs. Like if the mapping is defined by this keyword, and we can define mapping by our choices, that what we want to store in this mapping. Like we want to store address, and we want that when we call it from a particular address, then it must return the total number of coins that a person or we holds. So we will just correspond it with uint 256 because we want to input addresses and get uint 256 positive integer. So we will define mapping as mapping address equal to uint 256, and we will define it as public because we want that anybody can access this mapping, and we will just write it as balance of because it will be returning balance of the cryptocurrency that the particular person holds, and we will just name it as this. Now in normal programming languages like in Java or JavaScript, when you initialize a JS file, then you also initialize with having a constructor. Like you set some value when you are starting that file, that it should be inputted in that file and that file should be run according to that. So that is called constructor. Because we are initializing our contract, then we will define some variable in the constructor, and we will define that variable when we will be launching our cryptocurrency. Like we can define constructor as this, and we will input uint 256 like positive integer, and we want that we will be inputting our total supply that we will be setting when we will be launching or deploying our cryptocurrency. So just name it as uint 256 total supply, just underscore, and the constructor is public, so no need to give it as public. And we will keep the balance of deployer. Like if you are the owner, then you will be deploying your own cryptocurrency, then you want that the total supply that you are inputting, you must hold that total supply so that you can transfer that amount to anyone, or you can launch a ICO. So simply what we will do is balance of, because balance of contains the supply that a particular address holds. So in case you are the deployer, then you must hold all the cryptocurrency. So that's why I wrote balance of. Now one more thing that I need you to understand. There is a public keyword in Solidity, MSG. MSG contains all the things that a user all the things. So there is a public variable in Solidity. So MSG contains all the value that a user has, like it contains the address of the sender that is doing the transaction, it contains the value that a user is sending. Like if we are selling our cryptocurrency, then someone will be sending some amount to buy some cryptocurrency, then the smart contract will know that amount by MSG keyword. So we will just msg.sender. So msg.sender, as I told you that MSG is the public keyword. So MSG sender simply tells us that who is doing the transaction, who is launching the smart contract or launching the cryptocurrency. So we will just simply write it as msg.sender and keep it as total supply. Now it is pretty much clear from this keyword, like msg.sender is the address of us, that when we are deploying cryptocurrency, so balance of our address contains the total supply of cryptocurrency. Amazing. So this, now we will deploy our contract as we have written till now and check that whether the things that we are written are working properly or is there any issue in that. So just click on compile and it will compile the smart contract, just showing a stupid warning, and leave that and just go to that. And as I told you that this is the address of us from which we are deploying. The remix ID gives us 10 addresses, and leave the rest of part, and this is the dev token that we are deploying. Now keep the total supply as 1 million. Okay, but wait a second, as I told you that we are keeping the decimal to be 18, so we will see all the things by dividing 18 and multiplying 18. So if we are transferring one token, then we are transferring 1 into 10 to power 18, because our decimal is 18. So just paste. Now I have inputted 18 decimal before 1 million that we wrote earlier. Now we will click on deploy, and it is deployed correctly. So now we will click on the get function and check whether the function are working properly or not. So we will click on decimals and it is showing us 18. We will click on name, the dev token, we will click on symbol, it is DEV. And I forgot to do one thing, like we also, when we are deploying our smart contract in a constructor, we also have to set the total supply. So we will just total supply as the amount that we inputted in our constructor. So we will just click on delete it and just deploy it again. Okay, I forgot to compile it, so just compile it and we have done the required changes, and we will deploy the smart contract again. So we will check by clicking on the get functions. So it is showing the correct symbol DEV, and it is showing the total supply as 1 million, as we have kept 1 million, and also the decimal it is showing properly. You can also check by going to this website and showing correctly. It is showing the decimal as 18 as we have set in our smart contract. And if we will copy our address, this is the address that we used while deploying the smart contract, and we will click on this and we will check the balance. Then the balance of deployer, like we are the deployer, that the balance of deployer is 1 million while deploying the cryptocurrency. So it's now we will start coding our cryptocurrency that we left in the previous video. So in this video we will write the transfer function, like we are transferring some of our cryptocurrency to another person, and we will see that how we will exchanging our cryptocurrency with Ethereum, and we have to write another contract for that in the later video. But as of now we will write transfer function. So what are the function? Function is a set of rules that is defined and particularly, and that is called again and again, and that follows the same logic. So we will have defined the following steps that the transfer function has to follow according to the logic. So first of all, according to first comment, we have to define the transfer function. So we will simply write function and write it as transfer and define it as public, so that anyone can transfer their cryptocurrency that they are holding, or we can transfer our cryptocurrency to someone. So transfer function. So according to this, let us just copy paste. Now transfer function must contain two inputs in this, two input fields. One is the address to which we are sending our cryptocurrency, and second, the amount that we are sending the cryptocurrency to, that how much amount that we are sending. So first of all we will define as address and like _2, and secondly we will define how much amount we are sending to a person. So just _amount, or we can say we can say amount. Now just we will delete this. Now we have to check one condition, but a basic condition, like if you are sending some money to another person, then you have to check that if you have that amount of money that you are sending, like if you have 5,000 rupees and you are sending 10,000 rupees, then your transaction must fail, and that's what we are writing. So to check the condition in simple languages, we use if else. So we can use it as if balance of, because we will call balance of by this. Now we use now in simple programming languages we use if else. So we will use if else condition in this. So if the user that is sending some crypto or amount, if it has enough amount in his balance, then the transaction will continue. Otherwise we will show that you can't do transaction. We will show a warning to the user. So we will just simply write if condition, and we will write the logic, like we can check the balance of a user by just typing balance of in it. And as I told you, msg.sender contains the address from which the transaction is taking place. So if a person is doing transaction, then msg.sender will be the address of the sender. So we will just simply write msg.sender, and this complete phrase will return that how much balance the user that is sending contains. And we have to check a condition that the balance of msg.sender must be equal to greater than. If it has more balance, then it is not an issue, but it must have equal balance that he is sending. So we will just simply compare it with amount and just type, and we can do in else condition something else. So this is the basic programming languages. So this is what basic programming languages do. But in Solidity, we do it in a very different way. So just we will delete this, and instead of if, we will type a keyword require. So require is similar to if and else, and it also checks that if the balance of MSG sender is greater than or equal to amount, then it is not an issue with the user. But if the balance of MSG sender is less than the amount that he is sending, so he will require statement will show the error. The require statement will show the error, you have not enough balance, right? And just we will simply compile in case we have any syntax error. So it is just showing us warning, so not an issue. Just warnings are some like it keeps on showing some warnings. So it is showing the warning, don't need to comment. Now we will be writing the core logic for the transaction or transfer function to take place. So what we have to do, we have to decrease the amount that the user is sending from like if the user is sending $100 if the user is sending 100 cryptocurrency to another person, then we will be decreasing it, just typing minus equal to underscore amount. And third thing what we will be doing is we will be increasing the balance of the user that is receiving cryptocurrency from the person. So we will be just typing balance of, and we will just simply type 2 in it plus equal to amount. So this is the basic logic of a transfer function, and we will be writing one more functionality so that our UI is improved, because when a transaction takes place, UI doesn't know that a transaction is taking place. So we use events. Events is the functionality of smart contract that triggers, like whenever the transaction or function is completed, then it's triggered very then it get triggered like a event is emitted, and the UI gets to know that the transaction is done and the user has transferred the function. So we can do some functionality with our UI or in React.js. So we define a keyword with event. So we will store particular information in our event, like from whom address the cryptocurrency is sending, and to whom the cryptocurrency is received, and what is the amount of cryptocurrency that has been sent. So we will just type it as address of like sender and address of to, and we will just type it as amount u into 56 and amount the receiver has received. So this is the event that we have defined here. It has just it is not a complex thing, it's just for UI part. So how we call the events in our function when the transaction is done, so we just type it as emit, because we are just triggering the event. So we just use emit keyword, and we will call the event name. So we forgot to give the event name. Event name we can give it as transfer event, right? Transfer event, and we will just emit transfer event, and we will just pass the event, and we will just pass the required parameter in this. So msg.sender is the address of sender, and underscore 2 is the address of receiver, and underscore amount is the amount that is received by the user. So it is done. So let us test the transfer function by deploying the smart contract. So we will just compile in case there is error. So yeah, we got some error. So I think there is spelling error. So we will just copy paste it and just try to remove. Yeah, it is removed. So spelling error happens in times. So we will just delete the previous smart contract that is deployed. And so this is a website E2Way. So Way is the smallest part of cryptocurrency. Like there are units in cryptocurrency. So don't need to worry. So we will just be copying it, and we will just pasting, because we want our total supply to be 1 million and 18 decimal. So just that. So just deploy, and we are pretty much done. So just checking that previous function are working fine. And let us check our balance, that we have balance of how much amount. So we have balance of 1 million. So let us just transfer whole cryptocurrency of our balance to the another person. Let us take the second address and copy it. We have copied, and let us transfer. So we have pasted the address in which we are transferring all our cryptocurrency, and we are checking the amount that we hold. Now we hold 1 million cryptocurrency as of now. So just copy paste that, and we will do transaction. Now if I'll click on balance of, it is showing 1 million on our address. This is our address, you can see 0x5 and 0x5. So when I'll click on it, it is showing 0. It means that the condition that is fulfilled. Now if we will condition is fulfilled, and then balance of MSD sender, that from which we are sending the transaction. So we are sending transaction from first address. So keep notice that when I transferred, just I clicked on second address, copied, and then moved to my first address, because my first address contains all the cryptocurrency. So don't make a confusion in that. So just the balance of our cryptocurrency decreased, and balance of this account that we copied increased according to logic. But if we will, let us apply it again, because now we have 0 cryptocurrency. Let us see that if this function works properly or it fails. It must fail. So if it fails, that it means that our smart contract is working properly, and we can move toward the next section. So just transaction, and it's failing. And what it is showing in the fail, that you have not enough balance, and that's what the logic that I wrote here, the statement. We will continue the video where we left off in the previous part. So now we will write a approval function for our cryptocurrency. So according to EIP20, so let us check how many functions we have covered till now, because if we cover all the function, then only Ethereum will take our will consider our cryptocurrency as a valid cryptocurrency. So we have a function of name. So we don't have currently a particular function for name, but if when we deploy our smart contract, so we have kept the name function to be public. So it is having a get function. So Ethereum will know that it has a get function. And we have symbol, and we also have decimal. Also we have a total supply. Okay, so we have a total supply, and we also have a mapping of balance of, and also we have wrote a function of transfer. Now we have to write transfer from function. Before writing transfer from function, we will be writing approve function. So also we have a transfer event. So we have covered pretty much almost 80% of the functions, 70% of the function. Let us change this transfer event to transfer, because the naming is particular in Ethereum, because Ethereum will know that it has transfer event, but transfer event it will not know because it is not known in this in their language. So now we will be writing a proof function. So what are the proof function for? It is written in the rules, so we have to write. But what is the functionality of proof function? So a proof function is basically like if I am holding 1 million cryptocurrency, then I am allowing my smart contract or another person that you can spend cryptocurrency, but it will be considered that I have spent. Like take an example, like you are building a bank on Ethereum, then you are taking allowances from the user. Like if I come to your bank and I invest 1 million Ethereum to you, then I will be giving you allowance that you can spend my 1 million Ethereum and invest it in another system so that I can gain profit. So it must be a trustful bank, so that's why I am allowing it. But it will be invested from my side, but I am given it authority that you can spend in my name, but profit will be mine. So that's what allowances come into place. So as we have known the what is the functionality of allowances, now we will define a function, approve, because before transfer from function we have to approve somebody, like we have to approve a body, so we will write a approve function. So just type it as approve and name it as public, and this whom address or a particular bank or a person that we are approving that amount, and what is the amount that we are approving, like we are approving 100 Ethereum, 1000 Ethereum to a particular bank or a person. So just we will type address in it, and we will just define a spender. We will just name it as spender because it is spending our money from our behalf. We have given we have given him or it allowances, so it is spending from our behalf because we have given him allowances. So just type it as address, and we will also type it as amount underscore amount, previous as we wrote previously, address of approval and amount. Now before approving to a person to spend on our behalf, we have to define a mapping, as we defined the mapping for balance of, that were keeping track of what is the balance of a particular user. Similarly, we will define a mapping of approval that will keep track of how much allowance is given to a particular person and how much he can spend. So we will just type in nested mapping. Like you may have heard of a array. There are two types of array. One is 2D array and one is 2D array and one is 1D array. So in 2D array, if you have to get 2 value, then what you will be write? You will write that I have to get 1, the first array in this 2D array, and the element at first position, second position. So we will type 1. Similarly, mapping also have a way so that we can type 2 addresses in it, like one address from whom the allowance has been given, like I am holding 1 million ether, so I am allowing some other person. So we can just simply type it as, so we want that a of msd.sender, so we want that a of msd.sender is allowing another person like spender address, let's support it as, and we are giving him allowance of some amount, like say 100,000. So we will define a mapping keeping in mind that we want this functionality. We'll type mapping and we will just type address because we want to get allowance by typing address in it. And now what we will do, we will define a one more mapping. As I told you that there are 2D arrays, but mapping are not 2D, there are nested mappings. So just we will type address and uint because we want to get allowance, public and allowance. So as I wrote this mapping, you may be confused a little bit. So let me explain you. In this mapping, we are storing here the address from which the allowance has been given, like our address that we are allowing someone, and here we will be storing the address to whom allowance will be given, like to a bank, and this is the amount of which the allowance is given. So we can address it as, just type allowance. So we will write msg.sender because we are giving allowance to someone, and we will paste here the spender address, and we will give the amount here. So it is very simple, don't need to confuse anything. So just we will do similar thing in this. We will allow someone to spend on our behalf. So what we will do is, we have defined a mapping allowance and just paid the same logic that I explained you above. Here spender is the address that we are passing, which will be spending on our behalf, and we will increase its allowance because we don't know that it has allowance from us from the back or not. Now similarly, when we defined an event, when we transfer the function, we will also define a approval event because it will be emitted and UI will get to know that the person has been given allowance. So just type event approval, and we are giving we will giving from init address spender and how much amount he has been given allowance. So it's pretty much clear. So we will just type emit in it, and we want to emit approval event, and we will be typing msg.sender spender, the person who is spending our money, and amount. So it is pretty much easy function. Now we will test this function by deploying the smart contract. Let us first compile that smart contract. Oh, there is an error, so just a typing error. Allowance, yes, it is compiled successfully. So just going to e2way, copying the 1 million in 18 decimal, just passing this is in a constructor, deploying, and just you can see that here there is two more things. One is approve mapping and second is allowance function. So let us give allowance to second address. Just copy this second address and move toward our first address that is containing all the balance. So let us first check the balance. Okay, it has now 0 balance. Okay, we have okay, second address is supposed to have a 0 balance. Now let us just call the allowance. So we will paste our address in the first place of mapping, and we will paste the second address that we have copied from here in the second position. Just by seeing the mapping, here is the address of person who is allowing, and here the address of person who is spending in name of this person, and this is all about it. So we will just simply call it, and yeah, it has now, as of now, it has 0 allowance given by the first person. So just we will approve it. So let us approve it. So this is the address of second person. So just paste it, and let us suppose give it as 1000. We are allowing it to spend 1000 crypto. We leave the thought of 18 decimal as of now. Just transact, and the transaction has been done properly. Now let us call the allowance and let us check what is the allowance of the person increased or not. So let us call, and yeah, you can see that we allowed him to spend 100, so it has allowance to spend 100 crypto in name of us. Now, but he can't spend because we have not wrote the spending function of allowance. We will continue our cryptocurrency course where we left off from in the previous video. We allowed someone so that he can spend cryptocurrency on our behalf. But in this, we will be writing a transfer from function so that the person whom which we are allowing can spend the money by calling transfer from function, because he cannot use transfer, and approve function is for approving and transfer from function is for the person or the spender who has been approved by the user. He will be using that function. So first of all, we will be writing a function transfer named transfer from. Just copy from it and we'll define it as public and just close it into parenthesis. Now it will contain 3 parameters. The first parameter will contain the address from which the money has to be spent. Second, to whom the money is transferred, and the third parameter is value. And there is also a fourth parameter, but it will not be included in function. It is msd.sender, that is spending the allowance that has been given to him. So we will define 3 parameters. First is the address from which the transaction, from which the money has to be deducted. Like I am giving allowance to a bank, then bank will be using transfer from function. Bank is the msd.sender in this case, and we are the from, because he is using our allowance, and to the money he is transferring so that we can gain some profit, or he will and the value that he will be transferring to some other thing or another person so that he can gain profit to us. So address 2, and we will write the UN256, the positive value amount, and we will just cut this. Now first of all, we have to check the balance of me. Like I have given allowance to a bank, then he is using transfer from. Then first of all, we will check that either that the allowance given by me, I have some money in my bank or not, because allowance can be fake. Like I have given allowance, then my bank then my money is spent by me. Like I have given allowance to you a bank 100 and I spent 50 out of it. So I have currently 50 rupees. Balance of me is 50, but allowance given to the bank is 100. So we will check that either the user from which the money has to be invested somewhere has the balance required in it. So we will just type require and write a fraction balance of, and we will just type not msd.sender underscore from. It must have balance greater than the amount that has to be transferred. So we will just type in the message that I have wrote a message that user from which money has to be deducted does not have enough balance. Now we will write a function. Now we will write another required statement. We have to check that the person, like the bank, is transferring the money to somewhere, so it must have allowance from us. So we will check that either the bank has the required allowance or not. So we'll just type require, and we will just check the allowance by calling this mapping. So we will checking the allowance by just typing allowance. So we will checking from msg.sender. So you may be confused that here we have given the msg.sender here and spender here, but you see that spender is calling this function. So spender is the msg.sender and msg sender is this in case. So it is cleared from that. So it must have a allowance greater than the amount, and the spender has a allowance. So we can show that the spender does not have required allowance. Okay, cool. Now bank, now suppose that bank is transferring the money. So the money, the real money is deducted from us because we have given allowance to the bank that you can spend our money to invest somewhere else so that we can gain profit. So the body that is receiving money from bank is here 2. So we have to increase the balance of 2 and decrease the balance from this address, because this address has given the allowance to this spender. So we will just balance off, write the balance off and type from here, and we will just simply decrease the amount that has to be transferred. Okay, now we have to add the balance of the user who is receiving money from bank. So just adding balance to and plus equal to amount. Now thirdly, most important, we have to decrease the allowance of bank so that bank cannot use our money in future. Like bank has invested $1,000, so it has allowance of bank is decreased to 0. So he cannot spend our money on our behalf, not anymore, because allowance is decreased. But if we give more allowance to the bank, then he can spend money. So we will just type balance off and we will just type allowance and msg.sender. Okay, and we will type first of all from and minus equal to amount. Now we will emit transfer event because transaction has took place. So we will just type emit and transfer and just type just type the transaction from which his has took place, the money is deducted, and to whom the money is added and the amount that is added. Also we will emit approval because approval is decreased. If approval of bank is decreased to 0, so we will just emit approval and just type just checking the parameters. Forgot from spender amount. So just type from and spender is msg.sender and amount is underscore amount. So we are pretty much completed. We are cryptocurrency now. Our cryptocurrency is completed. So we will check the transfer from and approval function by deploying the smart contract. So let us just compile it and let me check if there is error. So there is no error in the code. So let us just deploy it with the 1 million supply and just copy paste it and we will deploy it. Now let us check the old functions. So these functions are working fine. Let us check the balance of us. So we have a balance of 1 million token. So let us copy this address second and let's move toward previous address. So just approve this address of 1000 crypto. just suppose, just leave that 18 decimal, I will explain to you later on. So just keep on transact. So we have approved the second address here to spend 1000 on our behalf, to spend 1000 crypto on our behalf. Now we will move toward the second address, and we have allowance of 1000 cryptocurrency. So we will just paste the third address, and we have headed toward second address again. So let us just check. Yeah, so we have copied the third address with us. So we will just apply transfer from. So we are transferring from, so we are transferring to this account. From is the first account, okay, and msg.sender is hidden because it is the us that has allowance of 1000, and let us send 1000 to it. So we will just click on it, and yeah, the transaction has took place. So let us move toward third address and just copy it, and just let us check the balance of it. So it must return 100, otherwise our code has bug. So yeah, so it is 1000, so it is returning 1000. So our cryptocurrency is made. So from next video we will start working on crowdsale contract. We will build our ICO in which we will be selling our cryptocurrency in exchange of Ethereum. So let's move toward the next section. We will start writing the code for crowdsale contract. Now I have written the boilerplate code like pragma solidity, and wrote this line, and made this contract named as devtoken sale. So first of all we have to do these 4 points. First of all, we will make a variable which will contain the address of the admin. Then we will contain a instance. We will make a variable that will contain the instance of devtoken. I'll explain you later all these things. We will make a variable which will store the price of the token, and one variable that will store the count of token sold from the total supply. So let us make the variable. So just type a address public admin. Now we will create an instance for devtoken. So for creating an instance, we will import the devtoken that we have made earlier in the previous videos. So just type import and dev token. So we have imported devtoken from this file, and by importing this, all this code is present now in this. Now we can initialize the devtoken instance by typing dev token and make this variable as public and name it as devtoken. So why we have defined this instance? We have defined this instance so that we can use this instance to use the function of that smart contract. Like if someone is paying Ethereum in this smart contract to a particular function like buy token, so we want that the cryptocurrency should be transferred to that person account when the person is paying Ethereum to us. So that's why we can use, so by defining the instance, we can use all the functionality of the our token smart contract. Now we will define a price variable. So just u into 56 for non-negative integer and token price. Now we will define a variable that will store the total token sold. Total sold. We will make a constructor for crowdsale contract in which we will initialize some variables like what is the token price that we want to set for our token, and what is the address of the token, and we will also initialize and make an instance of dev token. Also we will initialize the variable admin by and set the address of the deployer in the admin variable. Now we will start making the constructor. So simply writing constructor and closing with parenthesis. Now in constructor we will pass two parameters. One is the token price and second is the token address. So let's do the token address first. Just type token address, and second is positive integer value. So just type token value. Now we will initialize admin variable by msd.sender. So msd sender, as I explained you in previous videos, msd is a public variable that contains all the information of the address that is deploying the smart contract or interacting with the smart contract. So msd sender is the address of deployer, because when we will deploy from our address, then it will be the address of us. Now we will initialize the token price and equal to token value. Now we will initialize dev token instance that we have created here. So how we will initialize it, because it is dev token. So we will initialize simply by dev token, typing dev token in it and writing capital dev token. So taking the parent as an instance and just inputting address, so that it know that all the function of dev token deployed at this address will be stored in this instance, and this instance will be able to use all the functionality of this dev token. So like transfer from, approve, and all the functionalities. I'll show you how we will use all the function of our cryptocurrency that we have made earlier in the video. So just moving toward the crowdsale contract and initializing the token address and just typing comma and just saving it. So the smart contract is compiled successfully. Now we can delete all the previous smart contracts, and just you can see that constructor contains two variables. One is the token address and second is the token value. So we will first complete all the functionalities of smart contract, and then we will test all the functionality of smart contract in details. Now in this video we will define how a person can buy token in exchange of Ethereum. We will define a buy token function in which person can input Ethereum price, also send Ethereum and get their tokens. So first of all we will follow this point and define the buy token function. Just simply function buy tokens and closing it with parenthesis. Now buy token function will contain only one parameter. So it's like one parameter, how many token that a person wants to buy. So just inputting it uint256 positive integer and total value that he wants to buy from the contract. Now first of all we have to check these conditions. Now first of all, before defining the buy tokens, we have to check two conditions. First we have to check that either this smart contract contains the cryptocurrency or not. So what happens with the working of the crowd sale is like, if we deploy the cryptocurrency, then we have 1 million balance of our cryptocurrency. Then if we want to sell our cryptocurrency, then what we will do is we will transfer like 50% of our cryptocurrency to a crowdsale contract that we are writing here. So some people will say that we can cheat, but if we are transferring 50 million, if we are transferring half a million tokens to this contract, then we don't contain half million tokens. So when people will come to the website, then they will see that this website contains half million of this token, so they can buy. And either if I am the admin of this smart contract, if I close this smart contract by destructing this, then what it will do is this smart contract will not buy token anymore. This smart contract will stop working. The Ethereum that will be kept in this smart contract will be transferred to us, and this smart contract will get killed. So there is no way we can cheat. Even we can't carry, even we don't contain our, even we don't have our own token. Half million are kept in this this smart contract. So there is safety, so that you can also you can buy this crypto from the smart contract. Now, how we will check that this smart contract has tokens or not? So we will check simply. So if we deploy the smart contract or any other contract, then it generates a unique contract address. So when we will deploy this smart contract, then this will generate a address, and by inputting that address in the previous contract that we written about cryptocurrency in the balance of function, then the balance of function will tell that this smart contract has half million cryptocurrency or not. So just type require, and we will type token, we will type devtoken. So as I told you that we can call all the function that are present in our devtoken.solve file in this smart contract, as we have initialized the instance of it in the devtoken. Just simply writing balance of and just typing address.this. So you may say that what is address.this? So address.this is simply the address that of this smart contract. When the smart contract will get deployed, then the address this contains the address of this smart contract. Now we will check the condition that it must be greater than equal to total value that the person is buying star. Yeah, it must be greater than the total value, or we can show the message that the smart contract don't hold the enough tokens. So we can simply write that the smart contract don't contain the enough tokens. Now second thing, we will check that the person who is sending the Ethereum to this buy token function has sent enough ether to it or not. So we will simply check by writing require. So we can get the how many ether is sent by a person by just typing msd.value in this. So we can simply say that msd.value must be greater than equal to total value. One is total value star the token price. So this simply explains that the MSD value, that the number of Ethereum sent by person must be equal to totals the one token price and the number of token the person is buying. And we can simply type the message. So we can simply just type you are not sending enough ether. The message will be displayed to user and user will send enough ether to it. Now after getting the ether from it. So just I forgot one thing, I forgot to write public keyword in this, and payable. So what is payable function used for? So payable function is simply used in those situations when we want to get ether in a particular function. So like msd.value will be used only when we are using payable keyword, because when we use payable, then the functions become red. Red means like we have to pay some Ethereum to this function so that this function will be executed successfully. So if we will save this, so it's compiling. Let me show that if we fail this, then msd.value is showing us error, because msd.value is always used in payable function. Because if we will be sending ether, then it means that it is a payable function. So it's passing. Now we will transfer the token to the user. So how we will be transferring the token to the user? So we will just simply apply devtoken instance dot transfer, and we will just type msd.sender and total value that is put by user to it, and total value put by user. Now you may say that devtoken.transfer. So here devtoken.transfer is run by this smart contract. So this smart contract contains like 500,000 crypto. So this smart contract is msd.sender in the inside. It is calling from inside. So this smart contract is calling the function. So the crypto are sent by this smart contract. Now we will increase the token sold. So just typing total sold plus equal to 1 total value, that will be appropriate. Now as I told you that events are emitted so that UI gets to know when we will build our we will integrate our smart contract with the wallet and React.js, then React.js will know that the transaction has been done and token has been bought by user. So it will update the value in the front end by fetching it from smart contract immediately. So we will just define a event cell. Just copy it from here. Just define a event. So in the event we have, just type the event. So in the event we are storing two parameters. One is the address of sender, so just by this, and second is the amount that he is purchasing, total value. So it must be compiling. Yes, it is compiling as of now. Now as we have defined this, we will emit the event, because emitting the smart event in the smart contract makes the UI alert that the transaction has been done, and you can show the things in the UI. So we will just save, and it is showing us a error. Why is that? And number of tokens, okay, it's the number of total value. We will continue our cryptocurrency series where we left off. Now we will define a function in which the admin of the crowdsale contract can end the crowdsale and can take his ether back to him, and tokens that are kept in it back to him, and the tokens that are sold to the user will be kept by them, and the sale will end. So sale can end like admin doesn't want to sell more of his token. He want to keep by himself some of his token. Like if he is selling 1 million token and his total supply of 1 million token, that he wants like 10,000 tokens that should be remained by him. So what we will do is he will destruct the smart contract, and he will get the left tokens in the smart contract. So the token that will be distributed, he has no relation with that. That token will be held by the users that are paying cryptos. So we will these 4 points. First of all, uh, we will define a function called endSale. We will check one condition, that if the user that is running the function endSale is the admin or not, and we will check it by the value of admin stored in admin variable. So we will simply require and check that either msd.sender equal to admin, and if it is not, then we will simply print you are not the admin, and just typing public for the endSale, and we will just save it. So it's showing this, I think, so no, not a worry. Now we will transfer all the remaining tokens left in crowdsale contract to the admin. So how we will do it? Just simply typing devtoken dot transfer and just typing msd.sender or admin. msd.sender will be appropriate because msd.sender will be the admin, and just typing address, just typing the balance of token left in this smart contract. So how we can get it? So we can get it by devtoken dot balance of address dot this. It is a similar thing that we did above of checking that the balance of this smart contract. So we did this because we are transferring all the balance left in this smart contract to the admin. So we will just simply write this and save, and it is compiling successfully. Now we will apply self-destruct. Self-destruct is a keyword. So self-destruct, what it does is, whenever we pass any address in it, then all the Ethereum kept in this smart contract, so when all the user will be buying the tokens, so all the Ethereum will be stored in this smart contract. Even admin doesn't own it immediately. So when he end the crowd sale, so he runs the function endSale, and there is a keyword called self-destruct. What it do is, it transfer all the Ethereum kept in this smart contract to the admin, and it finishes that smart contract, and no more transaction can take place in that contract after that. So we will just simply write admin. So I forgot to tell you that if any person is sending Ethereum to any function, that we write payable in front of that function, so that function can use msd.value or receive Ethereum. So similarly, if a person or address is receiving Ethereum, so we will write payable in front of it. Similarly, it is like a function. So when we will write payable to it, then it will not throw us an error. It is showing us an error. So I think there is a spelling mistake. So yeah, I think I have to keep it. Yeah, now it is compiling successfully. So admin here is getting Ethereum from the smart contract. So we have to write payable in front of it, because he is the receiver. So any function or any identity in the smart contract that is receiving Ethereum from anyone must write payable in front of it. Otherwise, the smart contract or solidity language will throw us an error. Now this is all about the section of smart contract and cryptocurrency. Now we will move toward the deployment. As of now, as we have completed both the smart contracts, now let's deploy these smart contracts to test blockchain, so that we can see the same ticker or symbol like USDT, and can also see our cryptocurrency in our crypto wallet MetaMask. So let us deploy this. So just click on injected web3 and just delete all the smart contracts. Now by clicking on injected web3, your MetaMask will pop up and it will ask you to connect to Remix IDE. So just click on Kovan testnet here. You can get Kovan Ether, test Ether from Kovan faucet. Just go to this website, login with GitHub and paste your address here. So I have already took 1 ETH, so it gives 1 ETH per day. So I have 1 ETH in my wallet. So I have connected my MetaMask to it and I have inputted 1 million supply in it and compiled it successfully. So I would recommend some of the changes as I matched it with the IERC20 guidelines given by Ethereum blockchain. There are some changes, like we have written decimal, so just rename it as decimals, and also just write indexed here, here, here and here. And there are more changes. One change is like that we have to return true when we do when we use any function in the ERC20 or our cryptocurrency contract. So just paste returns bool success and return true here at each function. So it simply do is like when we call these function, when they get executed, they return true. Just as simple. So so there is not anything complex that we are doing. So these are the changes that I have done. So just I'll click on deploy and the MetaMask will pop up. Just click on confirm and this is the transaction that will be going on. So as I told you that blockchain is a chain of blocks. So when we do a new transaction, then a block is mined or block is created, so some gas is deducted as a fees. So we are using testnet, so some gas is deducted. You can see that 1 ether has decreased to 0.98. So similarly, when we are doing with real Ethereum, some gas is deducted. So the contract is created and just so now what we will do is we will copy the contract address and we will click on add token, custom token, paste here and here. Yeah, this is the dev token that we have created. It has fetched and it has this 18 decimal precision just like Ethereum. So we have 1 million dev token as of now. So just transfer 1 million like 100 dev token to our another account just for transferring. So just transaction is taking place. So you can do these changes or I'll push this code on GitHub and you can just copy paste and check that what changes you can do. So I think transaction is done. Yes, when we will refresh it, so you can see that it is showing us the token tracker just like USDT when we saw earlier. So when we click on that, you can see that decimals are showing 18, supply is 1 million, 2 addresses. We can go on holders and you can see that these tokens are held by this address and 100 tokens are holded by this address. So we have deployed the smart contract. Now let us verify this smart contract. So just copy paste this and just click on verify and publish and solidity single file. Just click on the version we are using and no license. So it will automatically fetch the constructor parameter constructor, the bytecode in the constructor. So just I'm not a bot and verify and publish. Now our smart contract is verified. So just click on this and we can see that our smart contract is verified and it is showing us green single symbol. So we can also read contract and we can see the total supply and name, and these are all the parameters that we are seeing here. We can also interact with the smart contract from here, so it is fetching the data from online. So you can see that it is taking some time because it takes some time to fetch the data. We can also write contract, so we can also transfer our token from here. So just copy the address of first contract and go to second and just paste it and transfer 100. But as I told you, we are using precision similar to Ethereum, so we will just type 18 decimal after 100. 1 2 3 4 5 6 7 8 9 10 11. So we have wrote 18 decimal after this, so just connect it to web3 and just write the smart contract and we can transfer. So our transaction is not been confirmed, so yeah. Now you can see that here our transaction is showing that this transaction has took place, and we can see the transaction as it is showing us clearly that 100 tokens has been transferred from this account to this account. And we can also go to logs and we can see all the functionality. Now in the next section we will start building the UI in React.js from scratch and integrate our smart contract in the UI of React.js using web3.js, and also make our website on deploy our website on Netlify, so it can become a good project. And you can also show it in your resume and it will increase your chances for hiring. Also you can also get freelance projects. So till then, so welcome my gorgeous friend. So we will start making our decentralized application where we left off in the previous video. So in the previous video we have deployed our smart contracts and on Common testnet and also verified them. Now what we will do is we will integrate these smart contracts with our web application that we will make fully decentralized using web3.js. So before starting to the web part, we will be using React.js in this, and also we will be using web3.js. So before starting, what you can do is you can simply clone this code. So you can just copy this link and go to any folder. So let me delete it. And what you can do is you can just simply git clone and paste your link and just type enter. And if you don't have git terminal, then what you can do is you can directly download the zip and you can extract it and then start the video, then start the code. So let me just explain you what this code contains. So in this code, this contains the truffle files in the first folder. So you can leave that part because we are not using that. You can just go to client. So in this video, we will be making our web application using React.js. So if you don't know React.js, then you don't need to panic, because I'll be using very less React.js. I'll be just explaining Web3 more, because we are blockchain developer. So our more focus will be on Web3, not UI. So it is I'm not going to build a UI in this video. So I'm just explaining Web3 so that you can interact with the MetaMask using web application and interact with your smart contract using that. So what you can do is, so as you can see that there are various functions in there, like you can call these functions in Remix. So like name, decimals, But for user experience, like if you're doing any project or freelancing or a client side project, then for user experience, they need UI to interact with the smart contract, and also they need to do transaction if they want to buy the token via presale. So they will be buying the token with Web3 JS, so they can interact with the UI using MetaMask, and they don't need to use Remix and go to like verified contracts and connect with. So that's the purpose of Web3 JS, so that you can interact with the MetaMask easily. So what I did is I have opened the code in this. I've opened the code in my VS Code. So what I'll do is I have also started this code. So for starting this code, what you have to do is you have to simply go to client, or if you are not able to run this CD client, what you can do is you can open this folder simply in the VS Code. So I have just run npm start. Let me just again start it. So I've just wrote a name, simply npm start. So after npm start, our application at initial phase look like this. So it's the started version. So look like this. It has some like text1, text2, text3, like these are like dummy text, and this here React website, and here it is showing the address of our MetaMask. So let me show you. Like let's just create, and we are in account 2, 0x9, just note it and just connect it. And if I'll refresh, just note this 0x91, and I'll so address is changed. So this is fetching the address from the connected address here, and as you can see that it is connected to this website. And if I'll switch this and if I'll refresh, it is showing the first account. So let's start this video, and I'll just hide this terminal. So for starting the video, what we will do is I'll explain you the code, like the basic version, like what is happening, like what is the structure of this code. Like if you are not if you don't know React, then not need to worry, because like we are not a UI developer, we are a blockchain developer, right? So in app.js, let me explain you. So I have used React hooks. So React hooks is very simple. I'll explain in the upcoming videos, like just for the Web3 integrations. So I am just explaining you a big things. Like this is the function that will load the Web3 for us. So this is just a boilerplate code. Boilerplate code means like code that we have to write. So in this documentation, there is like in this documentation, I have just copied this. So this is the function that is like loading Web3, and this is a function that we will use to load blockchain data. So let me explain you what it is doing. So it is just leave this and let us just come to this. So it is checking whether the browser is MetaMask based or not. If it is not MetaMask based, then it will not load the blockchain data. So I'm just returning this function. So this function ended here only. It doesn't go further if the browser is non-Ethereum browser. So what is Ethereum browser? When you install MetaMask in any system, that becomes the Ethereum browser. Just to say. So we are So now what I have done is I have just initiated Web3 JS, and I have used window.ethereum. So what is window.ethereum? So window.ethereum is basically the explaining, like window.ethereum is like when you have MetaMask in web browser, then window.ethereum is having some functions. So using that functions, we can interact with MetaMask. So that's why so I have initialized the Web3 using window.ethereum. So this is the shit code. Let me just remove it. And so what this function is doing, So as we defined the web3 here, so what I did is, so I loaded the web3 that is in the Ethereum browser. So it returned me the all the functions of this window.ethereum. Then I initialized the web3 here so that I can use web3 to interact with various functions in future. So if you are not getting anything up to it now, don't need to worry, because like like code comes after moving in the video, so don't worry. So what it is doing is, so simply you can see that web3.e.get accounts. So this function here is getting all the accounts that are available in the MetaMask. So if your MetaMask contains 10 accounts, then your so it will return all the 10 accounts. So in the MetaMask, on whichever position you are, like if I have opened this account, so it loaded me all the accounts starting from this position. So this is at 0 position and one will be at 1 position. So if I'll open, so what I did is I checked if the account length is 0, then stop the function there only, don't need to go ahead. And if there is so what it will do is it will set the account at 0th position. So now account 2 is at 0 position. So let's see if it changes. Yeah, it is changing the address, so it's working fine. So now, so it is returning me network ID. So web3.e.net.get ID. So like if you are getting, like if you are thinking like you are not writing any code, and because these are the like boilerplate code, you have to write these function in every dapp or decentralized application you will be making in future. So you will be, so what is network ID? Let me explain you. So like there is a MetaMask, right? So some rules has been decided by Ethereum community. So Ethereum mainnet has network ID 1. So similarly, Coven testnet has network ID 2. So what I have said is, if network ID equal to 42, then it's okay. But if it's not, then like you can say that you are not on the current network that we are using. So if I'll just refresh, yeah, you can see that contract not deployed to detected network. So there's the window alert that I've set. So that's perfect. That's working perfect. So let me go to Coven and let's refresh. Okay. Now that's the things. So no need to go to above functions. That are all the things. So I'll just explain you in a bit. Like these are the HTML codes, and these are the conditions that I have set. Like if account equal to undefined, then show this and this. So no need to go there, because like we will be doing web3 first. And let's jump into web3 code. Like let's interact smart contracts from the React.js. So in the front end, that's amazing, right? So what we can do is, so what I'll do is I'll go to the smart contracts. So I'll just like this is the devtoken crowdsale, and this is devtoken, right? So let me go to devtoken, and it is compiled, auto compiled. Okay, and so what I'll do is I'll copy the ABI for it. So now you will ask, like what is ABI? So if I'll explain you in a simple way, ABI is a JSON file that contains the name of the functions in JSON format. That's it. So we have the address of smart contracts that we have deployed, right? And we have ABIs. So when we have to interact with the contract in the front end, what I'll do is I'll use the contract and the ABI to create an instance, and from that instance I'll call the functions. So what ABI will do is, in ABI it will contain all the functions and smart contract address. So when I'll fetch, it will request the smart contract address, and smart contract instance have all the functions. If the API has more function and smart contract address has no function, then it will not get fetched. So in simple way, API is just like having, like, let me explain you. Like, let's just give it a name as token API dot JSON, man. Yeah. So what I'll do is I'll just API and storing it in JSON format, and I just copied it. So let me just explain you. So yeah, let's jump into it. So so you can see that allowance. So allowance is a function. Remember that we used in the remix to get allowance of a person. And let's move ahead. Yeah, you can see that approve is a function that we approve somebody to allow our like balance on our behalf. You can see now, you can see the decimals was a function. Yeah, you can see, I can show you. So decimal is a function. 1 second. So you can see here, it's like decimal is function. So what Remix is doing? Remix is doing the same stuff. It is like it is having the API and contract address, and it is interacting by creating an instance here. So what we will do is we have pasted the token API, right? And I'll save it. Correct. And what I have is, I have with me the contract address, right? Devtoken. So what I'll do is I'll just copy it, right? And I'll just save it for now. I'll just comment it and we'll give it address of token, right? I think video is going amazing. I've been like, yeah, it's not good to like. So what we will do is now we will import the token API that we just defined in the contract. So what we'll do is like let's give it name token API from and contracts and just token API. Yeah, it's autocomplete. So we have the token API, right? And now we have come to create an instance of smart contract so that we can interact with smart contract in the front end. So what we will do is we will create tokens contract, dev token contract, let's suppose, right? And to create an instance, we use new web3.eth.contract. So it's also a, like, you have to use this, right? So new, it's a syntax, man. We cannot do anything. We contract, yes, and C capital, my bad. So what we are using, web3 is here we have defined. We have created an instance of web3 and we are using web3 from the browser and and where web3 is coming in browser, through MetaMask. Yeah. So now what we will do is, now we will input the function. So now at first position is take the API of the contract that we have imported just now. So we will just token API.API. And why I write API? Because just we can check it by control clicking on API, control just hovering over here, and token API because API contains the JSON file, right? That we just copied from Remix. So this, and second parameter is the address that we just copied from Remix. We are gonna do is let's just check it. We have checked it. Now let's just check it. So it has the instance. Here is the instance. So here are the methods. So you can see that you are getting familiar with this method, right? So let's just fetch something that we are fetching in Remix in the from the instance that we created in React.js. So let's just fetch name from here. So dev token, right? So what I'm gonna do is, like, I'll write name of token, right? And it is the instance that we just created. And what I'll do is I will go into methods and I have to call function name. I am checking it name. So name is the function, and it is a callable function, so don't forget to write call after that. And let's just console.log it, man. Name of token. Okay, and let's just see. So it is returning some promise. Okay, my bad. Don't forget to write await, because like it's a asynchronous function. It will get. So yeah, you can see that you are getting the data from the instance that you created just now. So dev token. So let's just fetch all the functions that we created to just play with it. It's just a practice. So what we can do is we can just fetch even decimal, right? We can fetch symbol and total supply. Symbol, total supply. So for symbol, let's just copy this. No need to write again and again the code. And what you can okay. So for practice, like just decimal of token, and I'll write await devtoken contract dot methods dot. So what you can do is, for not getting any errors with the name, you can just copy the symbol and just paste it, and it's a callable function. So yeah, okay, it was decimal of token. Okay, my bad. So just write decimals here. Okay, and let's just console.log it decimal of token and just save it, and let's just check our react. Yeah, you can getting the decimal of token. That's insane. And let's just do one more practice, and let's just symbol of token and await devtoken contract dot methods dot symbol dot call. So for not getting error in React, just check is the right spelling of symbol I'm writing correct. Just rechecked it, and just symbol of token log symbol of token. Okay, yeah. So you are getting the symbol of token. That's insane. Yeah. So name table, yeah, decimal. So okay, let's get the decimal. Let's get the okay. We got the decimal, we got the symbol, we got the name, and let's get the total supply. That's a different task for us. Yeah. Okay. So what I'll do is, and because I'll total supply of token await and devtoken contract as usual methods dot. Let's just do not get any spelling errors, because like S is capital, and if I write S capital, then there may be error in the React, and you will say that Smart is giving you bad code. So yeah. Okay, and just type it console total supply of token. Okay, just copy it from here. Yeah, and let's just see. So you will see that total supply of token is 1 million that we set it while deploying the contract. But I told you that there are decimals that I need to put. So there are some are 6 decimals. So we are writing the token in 18 decimal. So what we'll do is, I'll divide it by 18 decimal. So in Web3, to divide it by 18 decimal, because if you divide it by 18 decimal in JavaScript, it will crash at some point. Because if you have 100 million supply, then it will crash, because like decimals are getting way higher. It's by getting around above 25 decimal, right? So what is the function in Web3? So what I'll do is just keep it let. So you know, like what is the difference between const and let? So const is the variable that you define it, then you cannot change. If you change, then JavaScript will change you. It will give you error. And let is the function that we can define it and we can change it after that. So what we'll do is total supply of token. So what we can do is, let's just create a total supply of token. Supply of token in decimal in decimals. Okay, correct decimals. So let's just let it be const. right? We don't want anything so what I'll do is wait. So web3 dot uh, web3 dot. So what I'll use in web3 documentation, one is web3.8. So there are utils in web3 library that help us to convert our 18 decimal to any decimal we want. So web3 dot utils, web3 dot eth dot utils. Okay, no, web3 dot utils dot. So what is the code? So from way. So it is the syntax. So from way means, so this decimals like 1 million into 10 to power 18, that is stated in way according to Ethereum language. So what I'll do is from way. So it means that I am converting the decimals from way. I want to go to Ethereum because we are using exactly that decimals that Ethereum is using. So Ethereum uses, like if you want to send me 1 Ethereum, so according to Ethereum, you are sending 1 into 10 to power 18 because 10 to power 18 is a decimal, right? So from way. So what we are sending in way, we want to convert this function, right? And we want to convert it in ether, right? So let's just write it and let's just see what just come up. Total supply of token in decimals. Yeah. And let's just see if it's getting me yeah, you can see that 1 million. I'm happy to see that number. So it's giving me 1 error. Yeah. And what we can do is, yeah, so these are all the console.log that we just used. And similarly, we can play with the balance of user, right? So let's just console.log. These are like list of console.logs, right? So let's just pass away this. And okay, why it's giving me a, okay, no, okay, now I have to fetch the balance of user. It means whosoever address is connected, I want to show him the balance, man. I want to show him the balance. So we will integrate all this stuff with the UI. Don't wait. So just wait. Yeah, we don't wait. So like const, we have to use balance of. So balance of user, right? Okay. And what we'll use, await first of all dev contract dot methods dot balance of as the same. So balance of, but there is a difference. Balance of is requiring some address in it. So what we can do is, you know that we have a number of like accounts. So we are using account 0. So let's just get the balance of account 0. Don't use there is set account. We are setting account. So don't try to use this because this will still be undefined until this function gets over. If you are known with React, otherwise if you are following me, then just use this. Yeah. So what we will do is, now what we will, so we will write call because it's a callable function, right? Console.log, and I'll write balance of user. Great. Sounds great. And just console and just go to it. Okay. It's showing me 0. Yeah, because this address has 0 tokens. So what I'll do is, my first account contains all the tokens. So let me just show you. Let's just switch the accounts and let's just refresh the website. And now you will see 1 million here. Yeah, 1 million into 10 to power 18. So we have to convert this into ETH language from way, that the method that we used above, right? So what I'll do is, to show you guys this function is working great, I'll just there are two ways to transfer, right? So what I'll do is, first of all, I can use this function directly. I can use this function directly, and what I can do is I can just connect. I can just do add the address we are sending, and let's suppose we are sending 100. So what we can do is we can go to this array from ETH to way, yeah, and we have to send 100 tokens because our tokens are in 18 decimals. So I'll just paste it and just transfer, and you can see that 100 Dave tokens, MetaMask detected it, yeah. And second way is, you can what you can do is you can add this token. So I don't know why it's showing me, so let me show you expanded view and custom token, add this token address already added. So yeah, it's showing me that I have 1 million tape tokens, yeah. So other, if this doesn't get added in your MetaMask, then you can do this method. It will add your token. So now 100 token just got transferred from one account to, like, if I'll refresh, and you can see that it is giving me some another number, right? So let's just convert it to Ether language from way function by using the web3.utils.way function. So yeah, you can see it is showing 100. Let me just convert it into way. So what I'll do is I'll just okay, for practice, what you can do is you can create balance of user in way await dev token contract dot methods dot no, okay, I'll just got away with the flow. So await web3 dot utils dot from way, and what we have to convert balance of user and to which language, to Ether. And just console. Now let's console this. Let's just console it. So you can see that it is showing 100. That's amazing. That's very great. We are working with, and let's just see what it is showing. And it is showing 100 less, so it's working fine. Now we have almost covered the functions of it. Similarly, now we have almost covered the functions, and now we can cover the functions similarly for this. So what we'll do is, let's just, so we don't need admin address in the front end, right? We have done that functions for practice, so we don't need to show admin. If we want to, you can fetch it. So we don't need to show, like, yeah, we can fetch Dave token. We can we have to fetch token price and token sold, we need to fetch. So what we'll do is, let's just create a new instance of the contract to interact with that presale contract. So presale contract new web3.eth.contract, and here is the address and here is the ABI. So let's just get the ABI for this, right? So Dave crowdsale, okay, and just go to Dave token sale only, select it. Do not select Dave token, otherwise you will get errors. Just keep in mind, yeah? Don't skip this part. And let's create another JSON file, and presale.json, you can name it whatever you want, right? I pasted it. Amazing, we are working great. And just import it. I'll import it. Presale ABI. You can also like name it crowdsale ABI if you are feeling different. From contracts presale.json, right? And what I'll do is I'll go to this, and at first place we need the JSON file. So crowdsale ABI that we did in the above section. Yeah, that we did above. And for address, let me get the address from the mix. So I'll just copy it. Just check if you haven't copied the same previous address, because it will give error, because that address is not gonna get you pre-sale sold and other amounts. So I think it's defined, and let's just fetch now. uh, let's just fetch let's just fetch dev token first. Token in pre-sale. Okay, await presale contract dot methods dot method, so dev token, right? Dev token, don't forget call, and let's just console it. Dev token in presale. Yeah, so 0x7, and I think this is this. Yeah, so it's working fine, it's working awesome. So let's just fetch other functions. Token price of pre-sale, and we can write via web3. No web3. Await pre-sale contract dot methods dot, what do we have to price? Token price. So token price dot call. So don't forget, it will return the price in ether, and we have to convert it in the it will return the price in way, so we have to convert the function. So let's just token price of pre-sale in way, just copy it, this variable in ether is equal to await. Okay, and web3 dot utils dot from way and token price of pre-sale and ether, don't forget to write dot ethers, and let's just console.log it. So one second. Yeah, it's fetching. Yeah, so we have set the price to 2.1 ether. So if you send 1 ether, then you will get 10 tokens. So it's like high price according to ether, because Ethereum is around $2,300. And yeah, but like we are on testnet and it's free for us, and yeah, and let's enjoy this enjoy this high price. Hey, so we are getting the right price, and let's just fetch the token sold of pre-sale, and I'll just copy it. Yeah, I'll just copy these two functions and just paste it, and token price, not price instead of price. I'll token sold of pre-sale, and token sold, and token price of pre-sale, not token sold, right? And let's just in ether. Yeah. Let's just fetch it, and it must show 0, so it's getting error. So I think I did some mistakes while copying it. Generally happens with me. So token total sold, oh my bad. So not token sold, it's I also have to show you one thing, like I have to change token sold to total sold. What are they? Control D. I think it will not work in Mac, or I don't know about it. So I am using Windows, and it also works in Linux. I think it must work in Mac. So just I'll control D up to the point I have to change the name, and I'll just press backspace, and I'll just type total sold, and it reduced my effort. It generally, yeah, simply. So total sold 0. Great, man, great. So let's just do is one thing. Let's just do one thing. Uh, let's just do one thing. So what we will do is I'll create a state. So what is a state? So in React, you have to like we used a function. We defined all the things in const and let and other things. So in React, we have to set the state so that HTML and CSS, because in React HTML and CSS are in the same folder. There is a JS file in which we are returning HTML and CSS, right? So we are storing the values that we fetched in a state so that we can access those states in the HTML, CSS, and that's how React works. So what we'll do is we will just create a object. So what you will do is like you can just create token contract object and set token contract object. Okay, and how we define a state in hooks, we generally write use state, and yeah, so generally we can define it in a single way. So let's just define. So we can like have different states of our way. So let's just leave it this, and let's just define the state like token name as token name, right? So just be specific, token name, because just be specific, like your state must not match with the const or let keyword that you defined. So you can say token name and token name, right? And you have to store string in it, so you can store string. Similarly, you can just copy paste it, and similarly, instead of token name, you can write token symbol, right? Symbol, and similarly, you can define token decimal mults token decimal. So let's just use 3 variable, and after that we will create more. So what I'll do is here is the token name, right? So what I'll do is set token name, so auto keyword, and name of token. So we just set a state in the while calling a function, we just set a state, so nothing changed, right? So what I'll do is we just set the state, right? Whenever you use a function, you like pass some variable, you store some like let's say you store that data in something. So similarly, we have stored the data in this use state, and we will access it by get function. So this is set function and this is get function, similarly that we are using in smart contract. So what we will do is now I'll explain you what's happening here. What's happening here is when in React, right? First of all, we are using hooks, right? So first of all, if you are not getting like, don't like pressurize yourself. You can also watch my previous video on election. In that video, I have built this starter kit from scratch. You can understand that code, and if you don't want to, then that's not an issue, because in blockchain Web3 is more important than React. So React is important too, yeah, I'll say, but Web3 is more important at this time because you are learning blockchain. So in this use effect in hooks, we generally let's suppose that this is the constructor, right? So constructor runs first, like that we understood in the solidity smart contract. So for what is it is doing? It is just calling this function, and also it is calling this function. So when the state when it calls this function, so I set this loading to true. So it means loading is true. So I have set if loading is true, then it must show this. So it must show loading dot 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 dot, right? So let me just refresh, and it will, yeah, you can see that it is showing loading dot 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 dot, and yeah, after the function, after the data is fetched, yeah, you can see that after that, like if I'll refresh, if data, it will show you for a couple of seconds because data is getting fetched very fastly. And what does this mean? This means that if account is zero, like if account is getting undefined, right? Like if account doesn't get like if account, like if there is null account, if it is non-Ethereum browser, then it will show you connect to your application or like install MetaMask. You can show whatever you want. Let's just come to this. So how can we use that token name that we set in this? So what we'll do is project. So let's keep it as project. So text one. So what we will do is, instead of text one, we will just paste the state that we have copied. So you can see that it is pointing to that. If you will not use in this, if you will paste it right this, it is just a simple HTML, right? It's just a simple HTML, man. Okay, yeah, token name. And if you covered with curly braces, then it assesses the state that we defined in React, and state token is the state, right? And let's br tag. Okay, no br. Okay, and similarly, what we can do is we can set the state, like we can set the symbol of token. So here is the symbol. So set token symbol, and in symbol of token, and we can access it by this get function. So let's just paste it over here. So yeah, it's Dave. So right. Okay, right. So now what we'll do is, let's just token decimal. Okay, and I'll just paste the decimal over here, and decimal of token. And okay, so I'm not used that. So yeah, that's what I was expecting it in the UI. So sometime it happens. So let's just backspace and close the curly braces, and now you will see 18. You must see 18. Yeah, it's showing me 18. Yeah, I'll just remove this button for now, and we'll show decimal. Let's just remove this row. I don't need it now. And yeah, so it's showing me like this. And what I can do is, I can, for decorations, yeah, and token symbol and token name, and now you will see beautiful text. Token name devtoken project, and instead of project, let's say uh crowd sale. Yeah, just crowd sale. So now we are doing just basics, like, yeah, basics. So yeah, similarly, what we can do is, we can just do this thing for each and every function we fetch right now. So what we will do is, let's just create more states, right? So yeah, let's just copy this, and we have to like balance of user, right? And just copy it and just paste it after set, and right. So you may be wondering that why I have a decimal in, like, so So balance of user will be in integer, right? And I showed it in string because it was returning a string. So balance of user, let's set balance of user. What is balance of user? Where is balance of user? So yeah, I can set it balance of user in way and I'll just get it by, and I'll just set in the React. So if you are like getting if you are seeing some functions that are not understandable, just leave it, because like it's the code that we will use in the future, and it is very beneficial. Balance of user, and I must get my balance. Yeah, it's 1 million less than 100 less than 1 million. So yeah, our application is working great and it will be awesome at the end of the video. So similarly, yeah, let's define more states because we need states. So let's just token sold in pre-sale, right? And there is also a function that is token price, in pre-sale, right? And there are more functions. There are more functions, and there is balance of and decimal. We did it. Symbol. We did it. Name. We did it. Mm, yeah. There is total supply. And yeah, we can also token price. So yeah, there is total supply of tokens, and instead of total supply we can use dev token address in ICO in crowdsale, right? It's dev token address in ICO. So what we'll do is it's getting pretty much confused. So what I'll do is I'll just remove all the console.logs for now. For me, you can just keep it. Just remove console, don't remove set. Um, console, alright, console, and I'll just remove console and set. Let's just take set here for cleaning purposes. Let's just take here and token distributor here, and name also here. It's just for, I am doing this for me for cleanliness. You can do it your own way. And now what I'll do is I'll just save, because keep on saving, because if you get any error then you will may get detected now. Then wait. Now set. So let me just remind myself what were token sold in presale, right? Set token sold in presale, and what I can do is token sold in presale. Yeah, set token to set total supply of tokens, and I'll set total supply of token in decimals. Set token price in presale, and just copy this, right? And one more thing I'm letting, like set dev token address. So I think we are fetching this dev token in presale. Yeah, and it's string, so let me just convert it to string. Sorry, my bad. And just save it, and let's see if there is an error or not. So no error. So now we will integrate with the HTML. So just copy paste it, and just copy it, just copy let's just complete the token first. So total supply. So total supply. So it must be 1 million. All the total supply is with me. That's great. Almost 100 distributed to second address. And what I'll use? Let's just cross it. So let's just use devtoken contract address. So okay, am I? So I'll just paste it over here and just see the result. And yeah, it's giving me right. So let's just small it because I like it small. Okay, just I am doing this by pressing shift and right, if you don't know, and just yeah, I think it's looking better in small. So let's just copy no copy this. Okay, okay dude. And now token price, it's the turn for token price. And just control D, the shortcut I told you, and boom, yeah, point one. Yeah, we can use point one. Token price in pre-sale, it's point one. So let me just check. It's point one. It means so it's a point one ethers. So let's just click it point one ethers. Now okay, it's point one ethers, right? Now what I'll do is let's just move it to last token sold. That's important to know the people, like how much token sold in the pre-sale, man. Just tell them. So just copy paste it and just control X, and token sold will be 0. So what I'm gonna do is I'm just gonna delete it, dev token sale. For now let's just do one thing. Let's just don't do anything. Okay, and now let's test it by moving it to second account. And what's it showing? So it's showing balance of user 100 and it's changed, and the rest of the things are same because rest of the things are common, right? So now what we will do is now we will try to buy tokens using the instance that we created. So we have to buy tokens. So to buy tokens we have to use so one token is equal to zero point 0.1 ether, right? So if I give 0.1 ether, I must get one token. So I have to create an input field and a button for it. So let's just create it, don't waste any time. So I'll just create a div, and in the div I'll just delete it, input, and input is created like this, and input, right? and value equal to abhi, let's say 0, and just does it. And I have to create a button, so button is this that I just deleted, so I'll just copy it and just paste it there, and I'll just see what it created for me. Okay, so yeah, that's what I want. So just to click on it, let's just change it to buy your, like, buy tokens, and you can just name placeholder as uh, input the ETH amount, right? Because I want to, if I'll input 1 ETH, then I'll get how much tokens? 1 token equal to 0.1 ETH, and 10 token will be equal to 1 ETH. So I'll get 10 tokens. So what I'll do is, now, so so what I'll do is, now, what I'm thinking is, like, I think I have to change some logic in buy tokens. So buy tokens must have this logic. Like if I send zero point 0.1 ETH and rate of token is 100, 100 tokens, so it must get multiplied by the amount of ETH that I sent. Like if I send 0.1 and rate is 100, so 0.1 into 100 is equal to 10 tokens. So I must get 10 tokens. So according to it, I must remove the total value, right? And I'll just remove, I just multiply this with the token price. Okay, so if we understand this logic, so it means that if I send 0.1 ETH and the token price is 100, so 10 tokens. So contract must have greater than 10 tokens or equal to 10 tokens. I am removing this logic because there is no sense of logic in this. And total value. So and total value. So what is the total value that is sent by? So total value will be this, add this, and add this. So that's the contract. So what I'll do is I'll just cross it, and if you are here for learning Web3, so you can skip this part, and I'll tell you how to redeploy. And let's just go to crowdsale, and I'll just their token sale, and I'll just input the address. And what is the token value? So token value must be token value must be token value or token price. So token price must be 100. Let's do it 1000. Okay, and just confirm it, and let's just wait for the transaction to be converted. Okay, and let's just buy token. So we can directly buy token, so we have to transfer token first, right? So let's just transfer tokens, and from here we will be transferring the tokens. And let's just transfer 1000 to this, and let's just wait. So let's just buy 0.1 ether of tokens, and just clicking buy. Just I'm waiting for the transaction. I think transaction just happened. So buy tokens, and I have deposited 0.1 and rate is 1000, so I must get 100 tokens according to the calculations. So let's just wait for the transaction to be happened. So meanwhile, what we can do is we can just go into our VS Code. We don't have to add much. So what we have to do is we have to just copy the ABI, and it's like it also a practice for you guys. So if you have to change some code and you don't find it correct, so what you can do is you can just paste it over here and just save it. And in app.js, what you can do is you can just copy the address for the smart contract that you just created and just paste it here, and data will be different, obviously, and token price in ether. So yeah, so that's the price, and let's see what happens. So here is the transaction. So yeah, so my logic is working great now. So what I'll do is I'll just remove this in token price of presale in ether, and just copy this and copy over here, so it will show the price perfectly according to 1000. So token price is 1000 token price in Visa 1000 token per ether. So let me just write it per ether. Right now we have to buy, so we have to apply buy function. So let's just write a function. So here is a function on click that I have prepared for you guys. So what I have to do is, first of all, we have to interact with this instance, right, that we created, but we cannot interact with that instance outside of this function, right? So what we have to do is, again, we have to store it in a straight, right? So presale contract, presale contract, presale contract, what we can say is, we can say presale contract instance, and set presale contract instance, and I'll create an object because contract is an object. So what I'll do is I'll just go here and just move above there, and just presale contract, right? And now what I'll do is, so let me just comment it. So what I have to do is I have to, like, let's suppose it's a on click, it's a function. So I have to call presale contract instance dot methods dot, what I have to call the function, I have to call buy token function, right? Buy tokens. Okay, and I have to input something in it? No, I don't have to input something. So I can so in call function I was writing call, and in the function that I have to do transaction, I'll write send, and in send I'll write from, and from which account it is happening. So I think there is a set function we used, so set accounts, so we can use account here. So from this account it is happening because account 0 is settled there. So I think just save it, I'll save it, and await contract dot from. Now also we were sending some value in this contract, right, in that section. So what we can do is we can in further we can just input the value, like if I want to buy of 0.1 ETH, then I can just simply input 0.1 ETH here and buy tokens, and I'll get 100 tokens. Or if I'll input 1 ETH and I'll get 1,000 tokens, right? So I'll input the value. So for now what I'll do is, let's just do one thing. So I have to input this in way. because we are seeing these values in ethers, right? We have to input this value in way. So what I can do is I'll just define a variable that will like that. Let's suppose that I am investing zero point 0.1 ETH to buy 100 tokens, right? So what I'll do is const in amount of ETH in way, right? And what I'll do is I'll use simply. So what is the method of web3? So I'll just web3 equal to new web3 dot new web3, and here is window dot ethereum, right? So I'll just move this above, and what I'll do is I'll do amount of ETH in way. So I'll just await web3 dot utils dot two-way two-way because earlier we were using from way and now we are using two-way, right? So we are converting two-way a, and we will pass this as string, and let's just comment it, and let's just console it amount of way. So now you will be thinking like how we will get this function. So what I'll do is on click I'll just rename it as on send by transaction, right? And what I'll do is I'll just apply on click here, on click property, and I'll set this function. So what it will do is on click this will call this function. So let's just open the console and let's just move here, and let's just so if I copy this and paste it over here, so so I'll just remove it. So let's just one. So I'll just paste it, and it is showing 0.1 ether, right? So yeah, it's working perfect. So what I'll do is I'll just uncomment this and I'll just paste it over here, and after that once this thing is done, we can just apply, we can just first of all let's refactor it, and let's just refactor it. Okay, one dot left. And after this we can just copy these two things. So this like these things tells if there is error then this thing happens. So let's just support if there is error, so window dot alert error, man, you don't have insufficient funds or something like that, you can show anything. And once recipient is there, you can show success. You can let's just do success now. Okay, now react is opened, and on buy function we have this function, so we are investing 0.1 ether in this function. So if I'll click on buy function, then MetaMask must pop up. So if I'll click buy, so MetaMask pop up, that's the perfect way for our journey, right? So I'll just click on confirm. So in MetaMask you see that 0.1 ether was automatically in it. So that's the 0.1 ether that we inputted was already in the MetaMask, so we just paid and we just got 100 tokens, and that's perfect. Now the task we have to do is we have to input something in it, right? We have to call it by inputting something in it. So what we will call is so let's just not input this function in it. So let's just input a in it, and let's just cross it, and a over replaces this, so this will work fine. Now in React I'll tell you, so I have to change the input field, so I have to type on change and I have to apply a state over here. So let's just define a state for input field, because for input field I have to have a state, and that state I will be changing through input field. In HTML CSS there is simple, but in React this is like this. So I'll just define this input field input field change input set input field change. So let's just copy it, use state, and let's just give it okay, so let's just give it 0. Okay, and set input field. So okay, so now it will show. Now let's just on change just leave it like this, and here just define a value, and value is input field change. So now let's just define a function that will change the data in the input field. So const change in input field, right? The spelling may be correct, spelling may be wrong. So in this, what I'm doing is like just I'll do e dot prevent. Let's just leave it. So what I'll do is uh, I'll just set input field e dot event e dot target dot value. So this is the this is the method that we use in React to set the input field. So I'll just click on change here and just save it, and let's see if it works. So also in this function, to check it, what I'll do is console.log e.target.value, and now I'll show you proof, right? So what I'll do is I'll just 1 yeah, input field is working great. So now let's just leave this a. Now let's just create a function on submit, right? So on submit function, what I'll set a condition, like if I'll set a condition like if input field change is having a value 0, like let's say if input field change, and let's do parse it because it's in parse int, right? So if input field change has value greater than 0, so we can think of it, else we can show a alert like null value is not allowed, right? And if the value is greater than 0, then what we can do is we can call this function, and we can just call await because it's an async function obviously, and we can make this function async as well. And what I'll input is input field change because it's greater than 0, because if I'll send value 0 in part1, then there will be no use to spend the gas everything. So what I'll do is I'll just create a function, and I'll just on submit on it, and I'll just click. Now let's just buy 0.1. So let's okay, null value not allowed. I think I have done some errors, so let me just check it. And what I have done error. So let's just check it, man. So let's just console.log is, it's the best way to debug this. So if I just input, okay, so why it's giving me show, okay. I think I must have done parse load, man, my bad. Okay, okay, now let's point one, and yeah, boom, yeah, so I rejected. So yeah, it's shown error because I rejected it. So let's just buy point 0.1 ether token. So you can see that point 0.1 ether is already in my wallet, so I am paying point 0.1 ether and I am sending tokens. And after paying ether, I must get 100 tokens. I have, how much ether I have? I have 1.5 ether. I have less ether. Okay. So let's just wait for it. I don't know why. Okay, yeah. So we got the 100 token, and our pre-sale is complete by this code. So I will so by this the code of pre-sale is completed. I'll share you the code of this repo as well as the starter kit and all the other codes, and now you will be able to build a pre-sale by your own, and you can do $1,000 project by your own. And in this market there is lack of blockchain developers, and I have currently I've gotten various pre-sale, I've built various pre-sale contracts, and you can also get a pre-sale contract client by on, you can search it on Fiverr and Upwork, and you can earn $1,000 easily. You have to just build the UI for them, and the code is completed with you, and pre-sale is done. And you can also do some changes in pre-sale, like there are various different type of pre-sale happening in the society, blockchain society. So now we are done for this video, and this is all about web3.js. And now you can build your own token as well as your web3. Yeah, you can also integrate web3 in the front end. Also you can integrate MetaMask. That's the greatest point. Now you have learned various skills, and if you find this video useful, just share it with various blockchain developers and other people so that you can also learn the blockchain technology. And just subscribe to my channel if you appreciate my hard work, and bye bye.